In the last video, given the coordinates of 4 points of a quadrilateral, we proved that that quadrilateral was a parallelogram by using the slope formulas and showing that the two pairs of opposite sides were parallel to each other. In this video, we're going to prove the same parallelogram fact again, except this time we're going to use the distance formula instead of the slope formula. Remember that we don't just need to show we can do more than just show that these sides are parallel. If we show that the opposite sides are congruent, that's also enough information for us to conclude that it's a parallelogram. So this time, we want to calculate the length of AB and the length of CD. And to calculate the length, we use the distance formula. The distance formula is the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And just like we did with the last problem, we're just going to substitute these numbers from A and B into the formula. So it's the square root of the difference between the x coordinates is 8 minus 3 quantity squared, and the difference in the y coordinates is 2 minus 1 quantity squared. 8 minus 3 is 5 squared. 2 minus 1 is 1 squared. So that's 25 plus 1, which is the square root of 26. We don't need to calculate this. All we need to do is figure out if this distance is the same. Same formula, x2 minus x1 squared plus y2 minus y1 squared. This time, using these coordinates. So the difference between the x coordinates is 10 minus 5, and the difference in the y coordinates is 6 minus 5. And once again, we see that 10 minus 5 is 5, and 6 minus 5 is 1. So this is going to be the same square root of 26. All right. Is this enough information for us to show that the top and bottom sides of the quadrilateral are congruent to each other? Yes, it is, because congruent line segments, all we need to know about them is they have the same length. So this is a fun little symbol that says, therefore, those 3 dots in a triangle, we can say that AB is congruent to CD. Is that enough information for us to prove that this is a parallelogram? Well, no. We only know that these two sides are congruent. We also need to know that the left and right-hand side are congruent. So see if you can do that. Pause the video, use these coordinates, use the distance formula, and see if you can conclude that the left and right sides are congruent. All right, so we have the length of AD. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. AD, that's 5 minus 3. And the difference in the y coordinates is 5 minus 1. 5 minus 3 is 2 squared. 5 minus 1 is 4 squared. So 2 squared is 4. 4 squared is 16. 4 and 16 is 20. So it's the square root of 20 is this length. And the length of BC we're going through the same steps. x2 minus x1 squared plus y2 minus y1 squared. This time, between these coordinates, the difference between the x coordinates is 10 minus 8 squared. The difference in the y coordinates is 6 minus 2 squared. 10 minus 8 is 2 squared. 6 minus 2 is 4 squared. So once again, we get that same sum of the square root of 20. So therefore, AD is congruent to BC. Is this enough information for us to conclude that this is a parallelogram? Well, yeah, because one of the things we know is that in a parallelogram, we have two pairs of opposite sides that are congruent. And that's exactly what we've shown here. We've shown that AB is congruent to CD and AD is congruent to BC. So therefore, ABCD is a parallelogram. Okay, once again, not hard work. Just going through step by step and applying the formula that we know to the coordinates that were given to us. All right, in the next video, we're gonna show a third way. This time we're gonna use the midpoint formula to show that that's a parallelogram.